Our lesson, which is lesson 3, which is talking about probability of multiple events. In the previous lesson, we talked about how to find the probability of one event, getting a 5 from rowing a cubic or 6 cubic numbers, or have a tail from tossing a coin. In this lesson, if we have now two events, we will know how can we find the probability of multiple events. We talked about the difference of dependent and independent events, that the dependence, that means happening of event A affect, or the occurring of event A affects the occurring of event B. Independence, that the event A have any, or didn't have any effect on event B. Now, and we said that if the two events are independent, we will see now how can we find the probability of A and B. Like, if the probability of A and B is the probability of A times the probability of B. So if they are independent, we will learn how can we find the probability of A and B. Let's see this problem here. Find the probability of independent events. At a picnic there are 10 diet drinks and 5 regular drinks. So we have drinks. Ten of them are diet and 5 of them are regular. There are also 8 bags of fat-free chips and 12 bags of regular chips. So from the chips now, we have 8 fat-free and 12 are regular. If you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and a fat-free chips? So look here, you have 2 boxes. You go to the picnic, you have 2 boxes with you. One of the boxes contain 10 diet with 5 regular drinks. So how many drinks you have? You have 15 drinks. 10 plus 5. And you have also a box of chips. At this box of chips, you have 20 bags of chips. As you see. Now, if you put your hand, you grab a drink, you take a chips, what is the probability? So you have 1 drinks with 1 chips. What is the probability that you get a diet drink? Now look at the words here. What is the probability of getting diet drink and fat-free chips? I have to find the probability of drinks and of diet drinks, and let's write them as DD. Diet drinks and fat-free chips. We said from here, I told you that A and B is the probability of have a diet drink multiply by the probability of have fat-free chips. Now, before that, I'm asking myself now, what is the probability? Is getting a diet, is getting any drink have an effect of getting any chips?
No,
No.
they are independent.
So because of that, they are independent. Since they are independent and they asked me about the probability of A, or event A and event B, I have to multiply them. Now, what is the probability of getting dieted rings?
15.
10.
Now, dieted rings. Well, how many one are diet?
10
10.
out of
10.
15.
How many drinks in all?
15.
15. Now, let's come back to the fat-free chips now. How many fat-free chips we have?
20.
8
Oh,
8
8.
over
over
20.
20.
Yes. Then so we have 4 over 15. Now, is the answer greater or less than 1?
less than 1.
So that's mean this is correct.
Teacher, all the possibilities should be less than 1, right?
Yes, yes, the probability must be, not should, must be less than 1.
Okay.
Or maximum greater than 1. Sorry, equal 1.
Teacher?
Yes.
Teacher, till now I'm pressing with this one if it's independent or dependent. Like this one, how do we know that it's exactly independent? Like when you give us like this question in the quiz, how can we how are we going to ask ourselves that this is independent, not dependent?
Here, if you have 2 bags, if you get 1 juice, this effect that if you get a chips? Yeah, that's me. If I told you that, see, if I told you like you have wait, like drink milk هذا كمان شوية اللي هم البوتلز of milk مثلا bottle of juice. Okay, all of them are in bottles. You have if you close your eyes, you will see that they have the same shape. Now, all of them in one box.
Yeah.
You have a juice of strawberry, you have a juice of orange, you have a juice of fruits, and so on. Okay? Now, if I get 1 fruit, get any 1 fruit from this box. So does it affect the number of if you get 1 of juice from this box, does it affect the number of juices that remain in the box?
Yeah.
Yes. You tell me yes. When I take 1, example, I have 1 of 10. I have 10 juices. So I can say if I take 1, so I say I have 9 over 10. I get 1 from 10. Then after that, how many boxes we have? But later on, I will tell you about this. How many drinks now we have inside the box? We have 9 now. Since we have a 9, so I get the probability now of getting 1 from 9.
So they are dependent.
So they are depend on each other. Here, it's like they are independent. If I have 2 boxes. If I take 1 of them, if I take chips, can it affect the number of the drinks? No, because I take a chips.
No.
I didn't take a drink.
Because when you take chips, the number of the drinks will still be the same. And
yes.
even if you
but if I take chips, then I take another chips, they are dependent because I'm talking about the number of chips that the number of bags that I take from the first one depend on from the second one depend on the first one.
But like for this one, it's 8 fat and 12 regular. So if I take 8 fat, they're not the same as the regular, so it won't affect, right? Even if they are even if they are both chips, but they will not affect each other if they took 8 fat or 12 regular.
No, here.
Right?
If I'm talking about the drinks only, like I told you, what is the probability of getting 1 diet and 1 regular? You tell me
so
1 diet, you'll tell me it is 1 from 10. But this is a new lesson. That's why I didn't. It's the 1 from 10. And for the regular, you have 1 from 5.
Okay, so they.
I think you will. Now stay with me step by step, because later on we'll go talk about these things. You will understand it more. But by now, I think, look at this example here. You talk about drinks, chips. Two different things. Two different things, that means they are independent. They are not, the number of bags of chips didn't affect the number of drinks. Since they are not independent and not dependent or independent, so the probability of event A and event B will be the multiplication of event A times, or the product of A times B. Stay with me step by step. This is independent, so the probability of independent or two independent events, A and B, will be the product of event A times the probability of event B.
Thank you so much.
Yeah, welcome. Inshallah, another example you will see. Look at this one here. What is the probability that you get a regular drink and regular chips? So, look at this one here. You'll ask yourself, what is event A? Is an event A of getting a regular drink. Event B of getting a regular chips. Now, if I get a regular drink, does it affect the number of regular chips?
No, they are both different.
No,
from each
so
other.
they can, because of R, they are independent. So I will say it is the probability of regular drink times the probability of regular chips. Now let's come back here. What is the probability of getting one regular drink? 5 from
5/15.
5/15 times regular chips,
12/20.
12/20. Then let's now simplify. So it is 1/5. Or you can say it's 0.2 or 20%. Is it clear?
Yes, teacher.
Yes.
Okay.
Yeah.
So by now we learn what is the difference between independent and dependent, or how can we find the probability of event A and probability of So here, I'm sorry. Here we learn how can, or what is the difference between dependent and independent, and how can we find the probability of event A and B. A and B. Now let's see here now what is the meaning of mutually exclusive events. Like, what's the meaning of mutually exclusive events? Sorry. Like, I am with you now at 11 o'clock. Can say now at this certain time at 10:50. I am a math teacher at grade 10. I cannot be at this time a math teacher at grade 8. So I cannot be, so Mrs.Dima cannot be at grade 10 and at grade 8 at the same time. But she can be at grade 10 or at grade 8. So, like to be or not to be. So since I cannot be at grade 10 and at grade 8 at the same time, so I will say that the probability of being at grade 10 and being at grade 8 at the same time will be 0. It's impossible. But I can be at grade 10 or at grade 8. Is it clear now what's the difference between and or in mutually exclusive event?
Yes.
Yes.
So these now the events that cannot happen at the same time, we call them mutually exclusive events. Cannot happen at the same time. It can happen at grade 10 or at grade 8. But at the same time, at 10 and at 8, it cannot. Now, before see how can we find the probability of them, let's see now, or let's decide if these two events are mutually or no. Now, let's see the problem 3 here. You roll a standard cube number. Are the events mutually exclusive? Explain. You roll a 2 and a 3. Can you now imagine? Now all of us know that this is the number cube here. You know it, all of you know it, okay? So if you roll it, you have only you have to give a number. Can you roll a number 2 and a number 3 at the same time?
No.
No.
You see that
It's
I can
either
say
2 or 3.
or 2 or 3. So this is not mutually exclusive. The second one, rolling an even number and a multiple of 3.
Yes,
How it will be? Let's think about it now. I roll an even number and a multiple of 3. Now, look at me. Here I'm talking about number cube or standard number cube. So the maximum number here is 6. Now I want to write all the possible even numbers. What are they? They are 2, 4, and 6.
2, 4, and 6.
And the multiple of 3, they are 3 and 6.
And 1.
Is there a number can be a multiple of 3 and an even number? Is there a mutual number here?
Yeah, it's 6.
Yes.
It is 6. Yes. So which is 6. So I will say that this is not a mutually exclusive number, because they can happen at the same time. There's a number which is number 6 and be an even number and a multiple of 3. Let's have another example. You roll a standard number cube. Rolling an even number, so I'm talking about 2, 4, and 6, and rolling a prime number. What are the prime numbers here? You have 2,
1, 2, and 3.
3,
1, 3,
5,
2, 3,
and on,
4,
even on.
5.
No, 1 is not a prime number. So 2, 3, and 5. So is there a number can be an even and a prime number?
Yeah.
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 Which one?
2 and
2.
yeah.
Only 2. So A, yes, there's an event which is 2 at 2. This is a prime and even number. So it can happen at number 2. So I will say this is not mutually. Now, B, rolling an even number. So I'm talking about even number 2, 4, and 6, and number which is less than 2. That's me number 1. Can I rolling an even number and another number that is less than 2?
No.
No.
So it's mutually exclusive.
No. So I will say this is mutually exclusive. Let's have another example. 2 fair number cubes are rolled. So I'm talking about 2 cubes now. State whether the events are mutually exclusive. Explain your reasoning. The sum is a prime. Yes.
Teacher, letter B is mutually exclusive events.
Which one?
Letter B.
B, yes, this is mutually. A is not.
Okay.
Now, 2 fair numbers are rolled. State whether the events are. Okay, so we talked about number 18 now. The sum is a prime number and the sum is less than 4. Now think about it. Can I have, I'm talking about now here we have the possible outcomes 1,
Yes, it is.
2,
It's not
3,
exclusive.
4, 5, and 6. And in the other one, I have also the same numbers. 1, 2, 3, 4, 5, and 6. Now, I want now the summation. Can I have a summation of prime number?
Yeah,
Which one?
I can
Which
have
pair of
three.
numbers?
3 plus.
I mean, I can have 1 and 2, 2 and 1.
Yes, so yes, I can. So I can say 1 and 1. I can say 1 and 2. I can say 2 and 1. I can say 2 and 3, 3 and 2, and so on. So I have. Now, a number that is this summation is less than 4. Another event now, I'm looking about any 2 numbers. If you add them, you get a summation that is less than 4, like 1 and 1, 1 and 2,
1 and 2.
2 and 1. So is there a, and on, so on. Now, is there an event that will be, its summation is a prime and less than 4?
Yeah.
Yes, this one and this one, this one and this one, and more events. So it can be. So I will say
Teacher, they
that
should
number.
be the same, right? Like the summation of prime numbers, this number, they should be the same. That will be less than 4, right?
Not the same. I mean that the summation is less than 4 and the summation is a prime. I mean, I want the summation of a numbers of less than 4, yani summation it have to be 3 or 2. And less than 4.
Okay. Okay.
So I will say that number 18, not mutually events. Now number 19. The numbers are equal. Now let's come back here. We have the same numbers 1, 2, 3, 4, 5, and 6. And we have also 1, 2, 3, 4, 5, and 6. The numbers are equal. And the sum is odd. How the number are equal? Like 1, 1.
3, 3.
2, 2. 3 and 3. 4 and 4.
No, they are not
And 5. 6
because
and
we
6.
both will multiply
These are
by
the meaning of the numbers are equal. Now let's find their summation. 2, 4, 6, 8, 10, and 12. I want now one of these numbers that they are equal and the summation is odd. When or which from these summation is odd?
None.
None.
none, because they always will multiply by 2.
They are, all of them are even. All of us know that if the numbers are equal, the summation is even.
Yeah.
Any 2 numbers, if they are equal, the summation is even. So the summation cannot be odd. So I will say that this is mutually exclusive. Now, number 20. The product is greater than 20. This is the first event. and the product is a multiple of 3. Now let's write now here product that is greater than 20. Now give me the numbers that from here that if you multiplied them, you get a product that is greater than 20. 5 and
5 and 5.
5 and 5. What also? 5 and
6.
6. 6 and 5. 6 and 6. All of these, if you multiplied them, 5 times 5, 25. 6 times 6, 36. They are greater than 20. Okay. Now, the product is a multiple of 3. What does it mean?
Yes, 36.
That's mean oh yeah, that's mean here, one of them, here we have 25, here we have 30, here we have, here we have 30, here we have 36, and we can have 6 and 4, we have 0
Can
and
we
6.
say also 3 times 15, which is 45?
3 times 15, from where you get 15?
Like, we should choose from these numbers?
Yes, I'm talking about these numbers only.
Oh, yeah, cubes, okay.
So here I have a product that is greater than 20, and the product is a multiple of 3. Yes, we have 30.
Yeah.
A multiple of 3. We have 36 is a multiple of 3. We have a 24 is a multiple of 3. And also they are greater than 20. So it can be. So I will say that number 20 is not mutually exclusive.
Please don't erase this. Just a second.
Okay. Sorry. Is it clear?
Yes, teacher, thank you.
Yes. Yes.
Yeah, I'm waiting you.
Okay, teacher, I'm done. Thank you.
Okay. Now, let's learn here now how can we find the probability either event A or event B occurring. Now, so let's before that we learn how to find the probability of A and B. Now, if we said that they are mutually or not mutual. Of A and B, if it is mutually, we will say it is 0. If it's not mutually, we can find it. We can find it, sorry. This is for A and B. Now, and we say that also we can find, if we have two multiple events, we can find the probability of A and B, and we can find the probability of A or B. To find A or B, I have to say, what is the formula of it? It is the probability of A plus probability of B minus probability of A and B. This is the formula of it. Now, but they told me here, before finding A or B, you have to see that you have to come to A and B. If A and B are mutually, you will say that it is 0. So you have to stop here. If it is not mutually, you have to find it by multiplying A times B. Is it clear?
Yes.
Yes.
Let's have now an example. So before that, here let's repeat that if I have to find probability of A and B, A or B, I have to say it is a probability of A plus a probability of B minus probability of A and B. Before that, if I have A, I will repeat them here, A or B, it is a probability of A plus B minus A and B. Now, if it is mutually, that's mean A and B is 0, as we said before. So so probability of A or B, if it is mutually exclusive, it will be A plus B only. So the formula will be changed if it is mutually exclusive. But if it is not mutually, okay, it will be probability of A or B will be probability of A plus probability of B minus probability of A and B. Let's have now an example here.
Teacher,
Yes.
so like solving these kind of questions, how we are going to know if we're going to use combination, permutation, and like that? Like this question, if it's not written in it, we are going to use mutually exclusive events. Like how we are going to guess?
To guess what?
Like if I'm
You
going
have to ask yourself, look at the events. If they can happen at the same time, you will say they are not mutually. If it cannot happen,
what if they are dependent,
mutual.
what if they are independent,
So,
what if they are
no, not dependent and independent here. All of them are independent.
Okay.
Okay.
But teacher, in the quiz, you should tell us like if it's mutually exclusive or like that. So
Yes.
that we can guess
Yeah.
quickly.
Here you have to say that. Yeah. Now all of them now are independent. Since they are independent, it can be mutually or not mutually exclusive.
Oh, okay. So from
Then, if it is mutually, now then I'll ask myself if these two events are mutually. So this is its formula. If it is not mutually, this will be its formula. How can I know? I will read the question. I will look at the events. If the events are mutually, they have a formula. If not mutually, I will use the other formula. Look at here.
Okay.
At higher school, a student take only one foreign language each term. I have to choose, or I have to ask you to take only one foreign language. 37 of students take Spanish. So some of students choose Spanish. They are 37%. And 15% taking French. What is the probability that a student choose at random is taking Spanish or French?
Okay,
I wrote it like this. Then I will say now, probability of taking Spanish plus the probability of taking French minus probability of taking Spanish and French. Now, before finding, I told you, let's now examine that. Let's determine that. Is there any girl that take a Spanish and French at the same time from the question?
No.
Did
So
they tell me that there's
exclusive.
a certain of girls take Spanish and French at the same time?
No.
No. They told me that you have to choose only one language. So at this class, you can be at Spanish, you can be at French, you can be at Chinese, you can be at Arabic, you can choose any language. So you can be at only one class. You cannot attend the same or two classes at the same time. So what is the probability of Spanish now? It is 0.37. And French is 0.15. Spanish and French, there's no one can attend both of the two languages at the same time.
0.
Then I will add them here. 5 plus 2, 12, 3, 1, 4, 5. So it is 0.52. Is it clear now?
Yes.
Yes, teacher.
No.
Teacher, here we're not going in this one, or we're not going to make like the total sum and like that, right?
Sorry?
We are not going to make the total sum, like the total outcomes, like
No.
0.37 or like that.
No,
Okay.
I will not add them. Why? Because they are independent.
Yeah.
The Spanish is different than the other. Sorry. Now here, to the same, I think I have only less than minute. 90% of students take Chinese. What is the probability that a random is taking Spanish, French, or Chinese? Okay, I think I have only 1 minute. So I will
Actually, we have
stop
another
here.
period after.
Yeah, so we will continue in the second period. Thank you so much.
Okay, thank you.